G'day guys, in this video we'll be going over an introduction to the quadratic formula. So things like where does it come from, what does it mean, what do the solutions mean, how to tell how many roots there are, and what is this thing called the discriminant. Okay, so maybe the best place to start is the general equation for a parabola. And that is y equals ax squared plus bx plus c. Right? And depending on the values for a, b, and c, a parabola can take any different shape. So I can just draw some examples on the screen. Right, so one example might look like this. Right. Another example might do something like this. And another example might do something like this. One of the things you might notice is that all these parabolas have a different number of roots, right? And a root is just a fancy word for an x-intercept. So for example, this orange parabola has two roots, one here and one here, right? This purple one has only one root here, and this green one has no roots at all, right? So the whole purpose of the quadratic formula is to find where the roots are on a parabola. And the question is, well, how do we do that? Well, one of the things you'll notice is that every time a root occurs, the y value is 0, right? And that's kind of the definition of the x-intercept. So to solve for the quadratic equation, the first thing we can do to this general equation here is to let y equal 0. So I can just do that now. 0 equals ax squared plus bx plus c, right? And if we rearrange this equation for x, right, we get the x-coordinate of the roots of any given parabola, right, with a, b, and c given, right? And with a little bit of algebra, we can make that happen, and I will cover that in a different video. But for now, if we just rearrange it, we get x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Awesome. So just once again, if we solve this quadratic formula, we get a value for x. And that x value is the x value of the roots of any given parabola, right? And we kind of know the y value because the y value is 0, by definition of the x-intercept. And because we know the x and y value, we know the overall coordinate for any given root. All right, any parabola can have any different number of roots, 1, 2, or 0. And the question is, how can we tell that? And we can tell that through this thing called the discriminant. The discriminant equals b squared minus 4ac, right? And one of the things you'll notice is that in the quadratic equation, this discriminant is under the square root, right? And there are three cases. There are three cases for the discriminant, and you'll notice that they correspond with the three scenarios, either 0 roots, 1 root, or 2 roots. So if we look at case 1, the discriminant is positive, right? So what happens is that when we take the square root of any positive number, there are actually two solutions. So, for example, square root of 9 equals 3 because 3 times 3 equals 9, right? But also, the square root of 9 equals negative 3 because negative 3 times negative 3 also equals 9 too, right? So when we take the square root of a positive number, we get two solutions. And when we plug that back into the quadratic formula, we get two different values for x, which might correspond, which which actually does correspond with this orange parabola here with 2 roots, right? So just in short, when we see a positive number under the square root, we know there are 2 real roots to any parabola. All right. Let's look at case 2. When it's 0, right? When we take the square root of 0, right, we actually only get one solution. Because, I'll show you that, b squared minus 0 is the same as b squared plus 0. They're the same thing, right? So when we have a square root of 0, when we have a discriminant of 0, we still only get one solution. So this case 2 actually corresponds to this purple parabola here, when we only get one real solution. Alright, now let's go on to case 3. b squared minus 4ac is less than 0. It's negative, right? What happens when you take the square root of a negative number? We get some complex solutions, but there's actually no real solution. There will never be a real number that, when squared, gives a negative number, right? So when we take the square root of a negative number, yes, we get some complex solutions, but there'll never actually be a real solution, which is why when we take a square root of a negative number, it will correspond with this green parabola right here. It will never intercept the x-axis once. There will be no roots. Awesome, guys. That's it. Cheers.